All right, so for question number one, the goal is to figure out whether or not whatever is underlined is a parameter or a statistic based on the context of the question. All right, so there are a couple of questions that should be a bit easier just because of the language in the question. For example, if I look at the third one down, the fact that I'm taking it from a survey automatically means that I have a sample, right? So since I have a sample, then this percent of people must be a statistic, right? So some of the other ones might be a little bit trickier. So one of the things that you might want to look for is if you're confused between, hey, sample versus population, because it can seem a little bit similar at times, you can ask yourself, am I using this to predict about something, quote, larger? Because if you are making a prediction about something larger, then what you're looking at is a sample of some sort of population. So, for example, in this first one, the number of free throws made by a basketball player, well, that piece of information is just something about that one basketball player in a game, right? There's nothing in here that says, hey, I'm using the number of free throws to predict the number of shots that might be made over the course of a season. So, even though it seems small, it's just one game. This would be a population. Whereas if I look at the second one, notice now that I'm taking the number or the free throw percentage from 10 randomly chosen games from a season, I can see that I have a larger set. The season itself would be the population. The 10 randomly chosen games would be a sample. So thus, the player's free throw percentage over those 10 games would be a statistic. So the fourth one might be a little tricky, right? It's the average number of calls per day that I receive. But notice that there's nothing, the average number of calls per day I receive in a week. And I'm using that to make a prediction for the month. It's just the average number of calls I receive. There's nothing that indicates this is a sample. So this would also be a population. For the, I guess, fifth one, the median amount of time that each of the students in your class take to finish this homework assignment. That's information about all of the students in the class. That would be a population. Notice I could take this and say, I'm using the median amount of time that every one of you students takes to finish to make a prediction about, say, how all of my statistics classes would how much time all of my statistics class would take on their homework, then that would be a sample, right? So you could have the same set represent samples or populations depending on the context. And then the last one might also be a little bit tricky. It's the 5 richest Americans. It's not, I'm using the 5 richest Americans to then make a prediction about the 5 richest Argentinians or the 25 richest Americans. It's just the 5 richest Americans. These five would thus constitute a population. So since this is a population, this must be a parameter. The standard deviation of those five must be a parameter.